Today we're going to work on factoring out a GCF. This is the very first step in factoring. All factoring problems, you should always try to see if you get the greatest common factor out of them first before trying to do any of the other methods. Greatest common factor is something that all of them would have in common, so you might have a problem that looks something like this. With 5x plus 10, you're trying to see if there's anything in common between this first term and this second term. Think of it as reverse distributing. When you look at this problem, both of these can be divided by a 5, so that's going to be our greatest common factor, and that's what we're going to be able to pull out. So if we pull a 5 out of each one of them, that's going to be our greatest common factor. What we still have to do is figure out what's left. And this is where the reverse distributing comes in. If we were to take this 5 and multiply it by this first term, what would we have to have here in order to get our 5x? And in this case, it's going to be an x. We then would look the same way to see what do we have to multiply this GCF by here in order to get 10. And to get 10, we're going to need a positive 2. So we end up with 5 and then in parentheses x plus 2. You can see the way this works. If we were to turn this into an actual distributing problem, we would go and multiply here and get 5x. We would then multiply here and get plus 10. And you can see how those two are the same. So multiplying and factoring are basically reverse operations of each other. So one is going to undo the other. The other nice thing is you can use multiplying to go back and check what you factored. So if you multiply this out 5 times the x and 5 times the 2, you should come back with the original problem. Now, not only can we pull out coefficients and constants, we can also pull out variables and multiple variables. So you may have something like this. (10x squared y minus 15x y squared plus 20x cubed y). We're again looking to see what we can pull out. The easiest way to approach this, especially with multiple variables, is to look at the numbers and then each of the variables individually. So we've got a 10, a 15, and a 20. The greatest common factor between all of them is going to be a 5. But now that doesn't mean that we're done pulling things out. What we're also looking for is the individual variables. If they all have an x, we're going to be able to pull out at least one x. So since they all do, we can pull that out. You can only factor out the smallest amount, the smallest exponent, because you're going to have to be able to take evenly from each. I can take 2 from here and I can take 2 from here, but I can't get 2 x's out of this, so we're only going to be able to pull out 1. Same thing on the y. Since they all have a y, we're going to be able to factor that out, and in this case, 1 is the smallest exponent, so we can factor out just one y. So we now have our greatest common factor, and again we have to figure out what's going to be left. One thing to pay attention to is for each term you have up here, you must have a term inside the parentheses. Otherwise, when you multiply it out, you're not going to get that many terms back. If I only had 2 terms in here, when I multiply it, I would get the first 2, but not the last one. Now, 5 times what gives me 10? And it's going to be a 2. I need 2 x's, and I only have 1. So remember, with multiplying exponents, you're actually adding, so 1 plus another x is going to get me to x squared. I need 1 y, and I've already got it, so I don't need to put any more y's here. So now I'm moving on to the next term. 5 times a negative 3 is going to get me the minus 15. I have 1x, I only need 1x, so there's no more x's. I do need 2 y's, and since I only have 1, we need to add 1 more in here. And 5 times a positive 4 is going to get me to 20. I need 3 x's, I've got 1, so that means I'm going to need 2 more to go in there. I need 1 y, and I've already got it, so I don't need to put any more y's in here. So now I can close that off. This is factoring everything out. You not only have to pull out the greatest common factor, but you have to figure out what's left to make this an equivalent statement to here. Now a quick check by multiplying. I'm going to distribute all this back through. So 5 times 2 gets me 10. X times x is x squared, and there's still a y. 5 times minus 3 is a negative 15. I have 1x, and y times y is y squared, and then 5 times positive 4 gives me plus 20. I've got x cubed, I need to have x cubed. I have x squared times the x that's outside here gives me x cubed, and y. And when you look here, these two are in fact the same, so that means we factored it out correctly. No matter how many terms you have here, whether it's 2 terms or 50 terms, you can always try to pull out a greatest common factor. This should always be your first step for any factoring problem, even if you think you already know what type it's going to be. Sometimes there's a greatest common factor that you have to pull out before factoring using any other method.